Hello everyone. It is my great honor to present our research on the wide-angle beam scanning millimeter wave antenna array using phase-controlled Beam-Steerable elements. Recently, millimeter waves have shown great promise in many application areas due to their high accuracy and high transmission rate. The proposed millimeter wave antenna element has a dielectric substrate layer and two radiators, which is square microstrip patch and a square microstrip loop. The square patch is located in the center, and surrounded by the square loop. When port 1 for the patch element is excited alone, the predominant surface current flows along the x-axis, and exhibits a half-wavelength distribution. It indicates that the patch is operating in the fundamental mode of TM10. When port 2 for the loop element is excited alone, the current flowing along each side of the loop exhibits a full wavelength distribution. It means that the loop operates in TM22 mode. When ports 1 and 2 are excited separately, the distribution of electric fields of the patch and loop accord with the sketch, resembling the characteristics of the TM10 and TM22 modes, respectively. By synthesizing the radiation patterns of the patch and loop elements, the direction of the main beam can be reconfigured by adjusting the phase difference between the two ports. This is the simulated 3D radiation pattern of the proposed antenna element with 3 beam switching states. When the port 1 is excited, the antenna element has a broadside radiation pattern, which is state 1. And the beam direction is switched from -45 degrees to 45 degrees with phase difference tuned from -90 degrees state 2. to 90 degrees, state 3. 8 proposed phase-controlled Beam-Steerable antenna elements are arranged linearly in one row. The spacing between adjacent elements is 0.75 lambda. The overall size of the phased array is 6 lambda times 0.75 lambda times 0.07 lambda. This is the prototype of the proposed array. We obtained the beam scanning radiation pattern using the active element pattern method. The active S parameters of the proposed millimeter wave phased array still maintain a working bandwidth from 26 to 30 GHz, and the proposed array exhibits a peak gain of 13.2 to 13.6 dB in the normal direction. Within the operating frequency band of 26 to 30 GHz, the proposed phased array achieves a 3 dB scanning range of ±76 degrees with a grating lobe level of less than -5 dB. Compared to related works, the proposed millimeter wave phased array has a wide beam scanning range with a compact size and simple structure. Thank you for your listening.